Hello everyone. Today we are going to discuss very interesting topic: gravity's influence on antimatter motion. Introduction. Gravity is one of the fundamental forces of nature, governing the motion of objects with mass. While it's a well understood force in the context of ordinary matter, the behavior of antimatter under gravity has been a subject of scientific curiosity and investigation. Antimatter consists of particles that are identical to their matter counterparts but have opposite charge properties. For example, the antiparticle of an electron is called a positron. This distinction raises intriguing questions about how antimatter interacts with gravity. In this presentation, we will explore the observations and implication of gravity's influence on antimatter motion. The equivalence principle. To start, how gravity affects antimatter, we start with Albert Einstein's theory of general relativity. This theory introduces the concept of the equivalence principle, which posits that the effects of gravity are indistinguishable from the effects of acceleration. In other words, if you were in a sealed, windowless room with no access to external observations, you would not be able to tell whether you were experiencing gravitational force or if the room was accelerating upward. Antimatter and gravity. Since antimatter is expected to behave identically to matter in all respects other than charge, the equivalence principle implies that antimatter should experience gravity just like matter does. In this theory, antimatter particles like positron and antiprotons should fall under the influence of gravity in the same way that electrons and protons do. Experimental verification. Experimental verification of gravity's influence on antimatter is challenging due to the inherent difficulty in producing and manipulating antimatter. Antimatter annihilates upon contact with matter, releasing energy in the form of gamma rays, which makes it challenging to contain and study. However, there have been some experiments that indirectly confirm the effect of gravity on antimatter. One such experiment involves studying the behavior of antiparticles produced in high-energy collisions, such as those in particle accelerators. While these experiments do not directly measure gravitational effects, they provide insights into how antimatter behaves in the presence of other forces, including electromagnetic and strong nuclear forces. Annie dispenses future prospects. The study of gravity's influence on antimatter is still in its infancy, and much more research is needed to provide direct experimental evidence. New experiments and techniques for creating and manipulating antimatter are continually being developed, offering hope for more precise measurements of antimatter's response to gravity. Conclusion. Gravity's influence on antimatter motion is a fascinating area of research that holds the potential to deepen our understanding of fundamental physics. While we currently rely on indirect observations and theoretical predictions, ongoing and future experiments will help us uncover the precise nature of how antimatter responds to the gravitational force, confirming or potentially revising our current understanding of gravity in the process.